Breakthrough. What if we could teach protons to behave like electrons? I'm Steve Belair. Welcome to Breakthroughs. The next era of computing will depend on controlling light the way we now control electricity, and Stanford scientists have developed a trick that could do just that. To develop futuristic technologies like quantum computers, scientists will need to find ways to control photons, the basic particles of light, just as precisely as they can already control electrons, the basic particles of electronic computing. Unfortunately, photons are far more difficult to manipulate than electrons, which respond to forces as simple as the sort of magnetism that even children understand. But now, for the first time, a Stanford-led team has created a pseudo-magnetic force that can precisely control photons. In the short term, this control mechanism could be used to send more internet data through fiber optic cables. In the future, this discovery could lead to the creation of light-based chips that could deliver far greater computational power than electronic chips. What we have done is so novel that the possibilities are only just beginning to materialize, said postdoctoral scholar Avit Dutt, first author of an article describing the discovery in Science. Essentially, the researchers tricked the photons, which are intrinsically non-magnetic, into behaving like charged electrons. They accomplished this by sending the photons through carefully designed mazes in a way that causes the light particles to behave as if they were being acted upon by what the scientists are calling a synthetic or artificial magnetic field. We designed the structures that created magnetic forces capable of pushing photons in predictable and useful ways, said Shanhu Fan, a professor of electrical engineering and senior scientist behind the research effort. Although still in its experimental stage, these structures represent an advance on the existing mode of computing. Storing information is all about controlling the variable states of particles, and today scientists do so by switching electrons in a chip on and off to create digital zeros and ones. A chip that uses magnetism to control the interplay between the photon's color or energy level and spin, whether it's traveling in a clockwise or counterclockwise direction, creates more variable states than is possible with simple on-off electrons. Those possibilities will enable scientists to process, store, and transmit far more data on a photon-based devices than is possible with electronic chips today. Wow, right on. I'll leave a link to the full article in the description, and as usual, please like, share, subscribe, and take care.